there was a bigger problem which was concerning me at that point in time and which still concerns today is the global warming. We are building solutions for capture and conversion of carbon dioxide and storage into different geological formations. But I could clearly see that the impact a geoscientist can make will touch every life on this world.
You yourself are a founder of quite a few startups.
I see that the understanding of geosciences in different societal problems that we can address creates opportunities in entrepreneurship. And it's not just about the classroom teaching, but the exposure outside, which is built as an ecosystem. One of the most exciting aspects of being a geoscientist is going to the field work.
Hello everyone, I'm Harshit Awasthi, an undergraduate here at IIT Bombay. Today we are joined by Professor Vikram Vishal. He's a professor here at the Department of Earth Sciences, IIT Bombay. He's the convener of the National Center of Excellence in CCUS, as well as the professor in charge of Aspire, the IIT Bombay Research Park. He's a 3-time National Award winner, as well as 2-time Fulbright Fellowship recipient. His work lies at the intersection of geosciences, climate solutions, and energy. Here we welcome Professor Vikram Vishal.
Thank you, Harshit, for having me here.
Tell us a bit about your journey, because your journey has been very unorthodox. Not a lot of people, especially in India, where medical and engineering are the two broad fields that people go into, you chose geosciences. Not many people do that. So what was the reason behind this? Why did you find geosciences attractive and why did you go into this field?
As you mentioned, I am a faculty here at IIT Bombay. I joined here as an assistant professor in 2016 and as a student here in MSc Applied Geology in 2007. So I have been around this space for last 19 years or so. Before this job at IIT Bombay as a faculty, I was a visiting scholar at Stanford University, did my postdoctoral research there. And prior to that, I was a faculty in the Department of Earth Sciences at IIT 𝘬𝘰𝘐. There was a scheme from the government of India, which took some of the sort of top students in class 10th for an exposure to the national laboratories. And I happened to visit one of the national labs, which is on mine and fuel research. And there I got an exposure of visiting a sort of a dummy underground coal mine. And when I visited the mine, I was very fascinated about the subject of geosciences that was applicable there. Of course, we have mining engineers, playing an important role of producing, but then the ones who explore are also from this sector. So geosciences fascinated me quite a lot. And when I was looking at different subjects of sciences, whether it's physics, maths, biology, or chemistry, I read about geoscience and felt that it's very much concoction of all of these subjects. So that inspired me to sort of understand what geoscience is all about. And then I read more about it and I decided that there are so many opportunities in geosciences and I think it may be worthwhile to explore this subject. That's the reason why I pursued geosciences.
So a person's childhood or their family background really makes them who they are. So tell us a bit about what your childhood was like, what your family background was like, and how that influenced you and made you into what you are today.
I grew up in a steel city. So clearly I was influenced with a lot of scientists and engineers. And as you know, in the steel making process, you need the ores and the ores come from the mines. And the ones who explore and discover are the geoscientists. So definitely that was a bit of a coverage on geosciences that I could feel about. In terms of my family background, my dad was working as a mechanical engineer in the steel plant. And my sister was pursuing her degree at the Armed Forces Medical College. So I had both medicine and engineering at home, and those discussions were like very common in households. It happens, it was there. That's when I realized that I could possibly explore a little beyond the convention. And I found about geosciences, their applications, the role they play in the modern world, the role they are expected to play in the future world. I got that exposure in that mining visit. And so on, all of this collectively taught me to deeply look into the opportunities there in geosciences. And that's the reason why I ventured out into this. And last almost 22 years, I have been a student of geosciences.
So you've also worked in industry. You worked in a company like Tata Steel, which not many people actually associate with geosciences. So what was your experience like there? What did you learn from your experience there? Also, why after working in Tata Steel did you choose to get into academia, choose to do your PhD?
Where do the raw materials come from? Largely when we talk about the iron ore, they come from the mines. And the exploration that happens is by the geoscience fraternity. In fact, I always give the example that there was a geologist who walked through the remote areas, explored and found the big deposits that were appraised and that led to the settlement or establishment of a company like Tata Steel. So this was in the year 2008 when I was through IIT Bombay campus placements placed in Tata Steel. And interestingly, I realized that there are a good number of geoscientists and geoscience professionals working in many such industries of iron and steel. The experience was that how we can continue to contribute, explore new resources, go to some exciting places for doing field works. And then if there is a sense of discovery that comes when you achieve this by the basics that we deploy in the field, it's quite rewarding. So my experience at Tata Steel was very rewarding. However, there was a bigger problem which was concerning me at that point in time and which still concerns today is the global warming. And that's when I decided to quit my job and pursue research in understanding the carbon dioxide emissions and how we can abate and mitigate the carbon dioxide emissions by the process called geologic carbon sequestration, which is the area which I have been working since then and currently pursuing a lot of effort. As you mentioned about the National Center of Excellence in CCUS, which is the first such excellence center in the country, for which I serve as the convener. We are building solutions for capture and conversion of carbon dioxide and storage into different geological formations. This also comes from the background that geosciences has a lot of multidisciplinary aspects to it. As I did my master's in applied geology at IIT Bombay, I went ahead to pursue the PhD in earth sciences at IIT Bombay and in civil engineering in Monash University through the ITB Monash research program. And then when I went to Stanford to do my postdoc, I essentially worked with a chemical engineer and a geophysicist for my postdoc. And that actually gave me a full coverage of what all a geoscientist can do in the applications that are there and not taking away the very fundamentals of geoscience as a subject. And 3 years ago, when I joined MIT as a visiting professor, I was in the Department of Chemical Engineering under the MIT Energy Initiative. So I feel that these are the opportunities that have come basis of my background in geosciences. And of course, back then as a young boy, I didn't realize all the opportunities, but I could clearly see that the impact a geoscientist can make will touch every life on this world, on this planet. And that was very inspiring for me to think at that point in time. And I continue to live with that kind of an inspiration.
So at the time of counseling, like a lot of people, like even we did this last year, we were sitting comparing branches, comparing colleges. So not many people actually truly understand what applied geophysics is, which is why some people might miss out on this branch. So how would you explain to a student, sitting in 12th who's just given his JEE Advanced, like why should they consider this branch? Why is this branch worth considering according to you?
I understand all the students go through the physics courses, and if they find physics fascinating, we look for applications of principles of physics to geosciences, to the world of geosciences, to earth sciences. And the earth, as you know, goes as deep as the core, and it goes as far as the planetary geosciences. The principles of physics are most important. Essentially, you are still understanding the mysteries of the subsurface to surface to outside of the surface through the principles of physics. So if you have a passion for a science subject, this has a broad perspective of viewing wherever it can be applied for. That's one thing to think about. Second thing, that as a young student, I would understand that we look for the opportunities or where we can apply the knowledge of geophysics in different aspects. So that covers the entire gamut, which is from deep within the earth to outside of it. Whether it's a mission to Mangalyaan or Gaganyaan that we are talking about, or whether it's to deep drill the tunnels within the earth and go as deep as possible in exploring the mysteries of the earth. The application to oil and gas sector is there. The application in infrastructure is there. The application for geologic carbon sequestration is there for mitigation of climate change. And of course, there are very interesting tools and techniques in remote sensing to INSAR that are also present through which we are able to understand the earth. So finally, now we are all talking about the AI/ML aspect. And AI/ML is very deeply integrated because based on some data points that we are trying to understand the behavior of earth in whatever way we are trying to understand and explore and exploit. So in that respect, the principles of physics and geophysics becomes very, very important. So I think that the students can essentially look at it as a very fascinating science, which can help them explore more. And of course, with the changing dynamics, the number of opportunities is continually growing. So all of it combined could possibly be the way forward for the students to pursue a BS in applied geophysics at IIT Bombay.
So you just now mentioned about tools like, remote sensing and INSAR. Normal people don't really understand what these are and like what are their applications. So could you tell us more about these, how they're applied in your field and like how do you use them?
Sure. The way we look at it, for instance, if there is an underground metro tunnel being constructed in Mumbai, we understand that the surface is at a certain level. But how has it changed in last 10 years? And as the tunnel progresses, if there's any deformation on the surface by a few millimeters to a few centimeters, that we are able to measure using techniques like INSAR. So basically the satellites are there, and at different instances, the satellites are capturing the data. And the data points are given at a certain time and space. After, let's say, 1 day or 5 days or a month, there could be a change of that point, that location on the surface itself. So we should be able to measure displacement based on that. So if there is any upheaval or subsidence based on the activity that is happening, we will be able to predict it or project it clearly using the satellite data. Similarly, if you were working in hill areas where the slopes are there, where landslide could occur, so we can do a lot of ground instrumentation to measure any movement or deformation that's happening on the ground. But through the INSAR data, also satellite data, we can analyze them and measure the change that is happening at what rate. So this can also be used for early warning system for landslides. Similarly, in a mining sector, when we mine out the ore, we have a lot of waste materials which form a dump slope. And those slopes can also fail. So we are able to monitor that using the satellite data on a routine basis. So we can project and also sort of predict the changes that are expected to happen based on these tools. These are also the tools which use the principles of geosciences and geophysics application largely in the field of infrastructure. But at the same time, when we talk about the oil and gas, when we are extracting the oil from the deep within the earth, or when we are pushing carbon dioxide deep into the earth, there could be changes on the surface also. Now there are structures on the surface that can get affected. So we are able to measure and monitor. And once they are verified, necessary action can be taken to control any impact based on that. So that's the reason why we do these kind of tools and techniques. And there are many such tools which are present, which have application in geosciences. One of the most exciting aspects of being a geoscientist is going to the field work. And when we go to the field, we get closer to the nature. We walk through some of the unexplored terrains, walking through the nalas, through the roads where people have not traversed, going across the hills to the limit that the geoscientists have actually gone to the Antarctica.
Sir, like you mentioned, geosciences, especially the course we are doing, BS in Applied Geophysics, is an interdisciplinary field. It's an interdisciplinary course. So how well are the students or the people in this domain equipped to deal with, these emerging areas of tech and science, like, for example, AI and ML? So how do we use them in our domain, as well as, like, suppose if students take this course, can they apply this somewhere else? Or like how do they match up with, people in other branches?
So since you talked about AI and ML, so basically we do work a lot on the training the students for the tools in computational applications, high performance computing, and of course in terms of digital transformation that's happening, digitalization, and the soft computing tools, including the AI and ML applications. A simple example is that when we appraise a field to have a lot of oil and gas, so we drill only a few wells, right? And then we extrapolate the information that is there. The wells are like needles in a haystack. And from that, we extrapolate to the entire big reservoir and field and say whether it's worthwhile to invest tens to hundreds of millions of dollars or not to produce the oil and gas from that region. So it has been traditionally been happening, but as the reserves are depleting, we use the previously acquired data with some new sets of data, apply the AML tools and techniques to understand and project how much more resource is present and what we can extract. Secondly, when we get the information from drilling a well as deep as, let's say, 5 kilometers, and we extract the samples out of them, we may be missing out of the information in some of the parts. Based on the data from a large number of wells, we are able to extrapolate that and say that this part was missing, and that log can be predicted using this a certain AI and ML tool. Predicting the reservoir behavior, rock characteristics, principles will of course require the fundamental physical principles that are there. But at the same time, when we go with a bit of a hunch, it's better to understand the use of these different tools and techniques. Now, since the students are already trained in all of it, it expands their view of lateral thinking quite a lot. And that can definitely be extrapolated to different areas of applications.
Sir, as you know, our energy demands are ever growing. But there's also a need to sort of balance that with climate change, because as we know, climate change is a big issue right now. So how do geoscientists fit into that? How do geoscientists help in the energy sector, the environmental and the climate sector? And what is the need of geoscientists? Is there a need for geoscientists in these sectors?
Absolutely. There's a lot of need of geoscientists in all the domains that you mentioned. See, the world is still powered by the fossil fuels. Fossil fuels are coming from within the earth. Around 82% of the oil and energy requirements are met by oil, gas, and coal. There's continued demand for that because our population is growing. The world has exceeded 8 billion in population. So we want to provide energy security and energy access to the last citizen of this country and this globe. And while we are moving significantly in terms of renewables, but the journey is long and ahead, we have to march together. So from that point, fossil fuels continue to power the world, and those need to be further explored. But since you talked about the climate change issue also, we realize that we have achieved 1.5 degrees centigrade rise since the pre-industrial times of the earth. Last year, we touched that on one day, and in next 3 to 4 years, the average temperature would have been above 1.5 degrees since the pre-industrial times. So we need to curtail carbon dioxide emissions. That becomes a challenge because we are burning more fossil fuels to meet the energy demand, but also CO2 is a problem. So in that case, we can actually capture the carbon dioxide and put it into the back where it came from in the form of fossil fuels. It was there. So geological sequestration of carbon dioxide is also an arena which geoscientists will work a lot, because it is going deep into the subsurface. So we need to understand the subsurface. So all the skill sets that have been acquired in the oil and gas sector can be directly linked and applied to the geological carbon sequestration. At the same time, we have these principles of enhancing the oil and gas recovery using carbon dioxide. So that's a utilization pathway where also we need to know how we can understand the subsurface to enhance more oil and gas. In terms of coal mining, India produced 1 billion ton of coal in last year. And we have the target of 1.5 billion ton of coal production in next 5 years. That's because the demand is growing. We talk about nuclear energy also. The nuclear fuel generates a lot of waste which are very hazardous. So they are disposed again back into the underground. So nuclear waste disposal also presents an opportunity for geoscience graduates. In terms of energy, we still looking for geothermal energy. And that also essentially allows the cold water to be pumped in and we extract the hot water out and then to run the turbine. So that also requires, where exactly can we do this? Where have we mapped the reserves of good high gradient of heat which can be used to tap the energy out? We are hearing a lot on hydrogen these days. So there are different shades of hydrogen, from black hydrogen, gray hydrogen, to white hydrogen or gold hydrogen, which are essentially coming from the geologic formations themselves. So when there are these deposits of oil and gas, when we talk about methane and other hydrocarbons, we also have some large deposits of natural hydrogen which are located in different parts of the world. So exploring them, and if we are able to extract them, that's the fossil fuel, so to say, which does not release carbon dioxide when burned. It essentially oxidizes to form water. Those are the opportunities where we need to apply our background training and understanding and provide access to the cleaner fuels to the world at large. So from energy and climate perspectives, I think these are the way forward for the graduates of the subjects of geosciences to explore and continue to serve and make this world a better planet to be in.
As you said, this geophysics and the course that we're doing, BS in Applied Geophysics, is an interdisciplinary course. So what skills can students, expect to learn when they come here, take this course?
Definitely, the students get exposed to programming. And if you like coding and programming, you find it ways to apply the knowledge to geosciences. We do a lot of simulations, and all the principles of simulations start from the fundamentals. One is the physical principles, second is the way that we create the simulator. So all of them combined also is a great skill set that is acquired by the students and can be used. Then we have a lot of data. So if you have interest in data sciences, data management, and how to use the data, and we talked about AI and ML, how we essentially utilize the data for a better understanding is also a skill set that continues to come from the training here. We talk about software such as GIS softwares. There are also the other skill sets help us to understand the earth and their principles, which can be directly applied for. The area of environmental sustainability overall will also require all these skill sets that are integrated with the principles of geosciences and applied forward. So I think the holistic understanding of both science and the tools that they are able to apply will be very, very useful. Further, whenever we are talking about building signal processing, building tools to monitor something, that will need the architecture of electronic gadgets that are required. At the same time, we use Internet of Things to map things on the ground and put them on the cloud and then be able to monitor them. That also requires the knowledge of both the tools as well as the sciences. So all of them combined becomes a great combination if somebody wants to have a broader understanding of different tools and techniques to apply to the subsurface or surface. This is the way forward that we see as an opportunity. So you can see that we are getting the students trained in from programming to data sciences to electrical signal processing and so on. All these skills that are acquired can be applied to many other fields. And that's where the training of geosciences becomes very, very multidisciplinary.
Sir, nowadays, if you see, a lot of students are interested in entrepreneurship and, building startups as well. You yourself are a founder of quite a few startups. So what is the scope of building startups and building, these great big companies in geosciences?
The background of geosciences helps us to explore far and beyond. As I mentioned, I'm more interested in the challenges around sustainability, climate change, climate solutions, and the mitigation aspect. So my focus was how we can capture CO2 from the industries which are releasing carbon dioxide. India produces around 3 billion tons of carbon dioxide annually. So if we're able to cut down and achieve net zero by 2070, we need to handle the carbon dioxide that's being emitted, and that will be emitted in the future. So there we capture carbon dioxide and convert into useful chemicals. So one of my startups, UrjanovaC, is on that aspect. Another startup where I am also advising is on captured carbon dioxide being put back into the earth through geological sequestration in different rock formations. There also we have some unique tools and techniques that have been innovated. And the way that we can monitor the injected carbon dioxide is the purpose of the other startup. The third one, which I have been working on, is more like an agri-geosciences, which essentially allows the fertility of soil to be improved by using crushed form of a certain type of rocks like basalts, which are sprayed on the farmlands, and it takes up carbon dioxide from the air and sequesters that in the form of carbonates and bicarbonate in the ionic and salt form. So essentially, this will help us accrue a lot of carbon dioxide related carbon credits, removal related credits. At the same time, it also increases the soil produce. So I see that the understanding of geosciences in different societal problems that we can address creates opportunities in entrepreneurship. Second aspect is when you are well versed with the tools and techniques and you understand the gaps in that. Let's say we talked about signal processing, we talked about the different tools of use of electronics. If we are able to develop a wireless sensor network which can be deployed on the field for doing the on-ground instrumentation and monitoring, and that can be coupled with satellite-based monitoring, that can also become an opportunity for doing startups in infrastructure and so on for the earth. The third aspect which I feel is for the resources characterization and mapping and understanding. That's also a lot of startups are coming up. Interestingly, most of them require the skill set that I talked about is simulation, software, and AI ML. So if we develop a toolkit which can essentially map the unknown and tell us with more certainty, then the investors can actually drill the space and understand the subsurface and use them for either resource extraction or for dumping the waste carbon dioxide. The fourth one could be more on the policy advocacy, governance, based on your understanding of geosciences. So if we talk about building an environmental sustainability governance framework, then we are applying them on the earth. So how and why and where we should apply. That's also a great way to look forward. So essentially, the combination of the tools with the understanding of geosciences presents a plethora of opportunities where one can be an entrepreneur. Of course, we have to understand the market well. We have to understand what are the existing areas and then identify the problems and the gaps that can be filled in through these opportunities. So I feel that the new age geosciences going forward presents a lot of opportunities in all these sectors, including the mining sector, as I talked about the critical minerals and other aspects, rare earth elements. So essentially everything is coming from within the earth. And that's where we are also living on. So the combination of the two presents a lot of opportunities of entrepreneurship, and the 4-year rigorous training that you are expected to receive as a student of this department, I believe that there will be a much deeper understanding of these challenges, and the world will present you with opportunities for contributing through entrepreneurship in this domain.
So you've talked about, building startups in the geosciences domain. Now let's talk a bit more about how the IIT Bombay ecosystem actually helps students in, nurturing their ideas. You're a board member of Sign as well. And as I've already mentioned, you're the professor in charge of Aspire, the research park here at IIT Bombay. So how do you make sure that a student who has an idea gets the proper nurturing and the incubation to, make it big later?
I'm an ex-officio member board of Sign, which is Society for Innovation and Entrepreneurship at IIT Bombay. It's one of the first such technology business incubator in the country, which has generated unicorns, which has also has had professor-led startup being launching IPO. So basically, this is an ecosystem that works at hand. On one side, you understand the fundamentals. Parallelly, you build the science and technology and the technological solutions. And then you are there approaching bodies like Sign, which helps you incubate the idea and to take it to the market. And when that idea grows into the market, it actually forms the big industries and companies, which are founded by the students of IIT Bombay. There are many such examples. I'm sure you can read about such an ecosystem. So something like that is also happening from geoscience background students of this institute. Now, once the companies are incubated and they're out there and they have been there for at least 5 years or more, and then there are the bigger companies, of course, they become eligible to become the members of Research Park. As you mentioned, I am the professor in charge for Research Park. So Research Park at IIT Bombay essentially hosts a large number of companies on the campus. Now, from the students' perspective, if you see that there are companies on the campus, we can actually do our internships with them, whether it's during the summer or in semester. You have direct interaction with the industry. And that also helps us to understand how we are able to upskill ourselves, at the same time learn about the gaps that the industry is facing. So that becomes a problem to be solved, and you become an entrepreneur by trying to solve that problem. We have an oil and gas major as a member of Research Park, and we have our students being hired from IIT Bombay and also working in these companies through that channel. But at the same time, when the students do internships, they get to realize how does the industry operate. So for that, you don't really have to travel anywhere. It's on the campus. We have this 500,000 square feet space of Research Park, which is housed by the industries. So as I mentioned, it's not just about the classroom teaching, but the exposure outside, which is built as an ecosystem from the fundamentals to the big industries, are all right access to the students here. That's where I feel that the ecosystem is enabling the building of new science and technology, but also scaling them up so that it can reach to the masses far and wide and solve the problem at large.
So I'm sure this was, a very insightful conversation for all the people watching. But what would be one closing thought or closing statement that you would like to give to students who are considering this course or who are going to join this course in the future?
One is that your passion for science and engineering, if that's there, this is a field where you get to explore far and beyond. Secondly, if there are these challenges around the resources and climate that appeal to you, environmental sustainability, where you want to understand the earth better, this is the way to go forward. In terms of upskilling yourselves to different areas of application, it's the best thing that I see in geophysics bachelor's course that is at IIT Bombay is well framed around that. And eventually, as you graduate, there are these opportunities in the infrastructure, construction, mining, oil and gas, and climate mitigation companies. But at the same time, into entrepreneurship, which can help you build your thoughts into commercial ventures. So collectively, I feel that we need a great talent pool to come forward in geosciences. And if you think that you are one of them, this is the best place to be in.
Thank you so much, sir, for these great insights. I'm sure the people watching and the students watching would have benefited greatly from this session. And, hopefully more people get interested in geosciences because of this conversation.
And thank you for giving me this opportunity.